My name is Alex Chircop. I'm the CEO and one of the founders of StorageOS. I'm going to quickly bring you up to speed on everything StorageOS is and what we're doing and kind of what we're seeing in the market to set the stage, if you wish, for some of the rest of the presentations that we've got prepared for you today. As a little joke aside, I'm going to try and not step on any on-premises landmines, but if I do, feel free to call me out. Okay, so let's get started. So StorageOS is a software-only product. We're building a cloud-native storage platform, working with enterprises who are adopting containers and Kubernetes and deploying their environments, on premises or on cloud, or probably what's more common nowadays is some combination of the above. We've had a really good traction winning some deals with large financial services and service providers, and indeed, other organizations who are busy adopting Kubernetes. And in relation to this, we kind of feel that our product provides that reliable, stable, performant cloud-native storage platform for these stateful workloads in all of these environments. And with the timing this sort of tsunami of Kubernetes adoption that we're seeing everywhere, which we'll talk about a little bit more later on, we also have some interesting news in that we've just closed our Series B funding round a couple of weeks ago, which will help us grow and continue to deliver these innovative solutions as we scale both our sales and customer-facing technology teams. So I wanted to talk a little bit about this infrastructure dilemma. So, as most of you know, the storage is that foundational layer that creates that provides that platform for high availability and performance and scale. But of course, the challenge that we're seeing here is that enterprises everywhere want that cloud experience where they want to combine the availability and the scalability and the performance with a self-service provisioning and an on-off consumption model, and the automation that comes with the deployments and operations. But of course, this is not a new thing. This is probably being sort of a couple of decades in the making. And we've had some of these conversations over the last few years with Stephen and some of you for sure. Starting off with the commoditization of compute with VMware and hypervisors, and then infrastructure as a service and platform as a service in the cloud, and then on-prem, and then containers and cloud-native orchestrators, eventually coalescing on Kubernetes. And in fact, we kind of see, a fairly predictable journey that most of our customers and many enterprises are taking. Most of them starting off with containers, because containers are almost the de facto standard for all new applications. 451 Research recently published a report stating that 95% of all new applications are being developed in containers. And of course, containers are amazing because they break that dependency on individual servers. We remove all the libraries and the security patches and all the other bits and pieces that made a server special. And the container now is portable, and your application is portable. And of course, the minute that your application becomes portable, it lends itself to orchestration and automating the deployments and automating the scale. And in fact, based on the last CNCF survey showed that 80% of enterprises have now deployed Kubernetes in production in some form or another. And Kubernetes gives developers a superpower. It allows them to compose and make their application declarative. So effectively, they can specify the compute and the RAM and the networking requirements for their application. And Kubernetes, being the operating system of the internet, abstracts all of that away and just makes it happen on the underlying infrastructure, and throwing in a bunch of automation around scaling and healing and that sort of thing. But of course, as developers continue to adopt containers, we're now going beyond some of those early applications, and we're kind of getting to the point where even the backend developers are now using containers. In fact, the last surveys show somewhere between 60 and 70% of backend developers are also using containers, which kind of takes us on to the next point, that the concept of stateful workloads. All applications need to store state somewhere, whether it's a database, a message queue, a file system perhaps. And this is where StorageOS comes into play. So StorageOS provides this software-defined cloud-native storage that integrates with Kubernetes and provides an end-to-end platform for not just for all of the infrastructure needs. So effectively, developers move beyond just being able to define, say, compute or networking requirements, but now they can also specify storage requirements in terms of things like capacity, but also things like the attributes of their storage. So things like replication and encryption and compression and all of the things that you typically expect from an enterprise storage system. And this fundamentally allows all of these developers and enterprises to move all of their stateful applications into Kubernetes. And because it's templatable and because it's self-service and declarative and composable, it fundamentally allows them to build anything as a service. So we have customers building database as a service, CI/CD as a service, and interestingly, now that Kubernetes can also deploy and manage VMs, we even have customers who are building infrastructure as a service with Kubernetes managing VMs on StorageOS volumes. I also wanted to, before we kind of go into how StorageOS works, I wanted to share some of the trends that we're seeing, and I'd love to hear your opinions or your comments a little later. The first point is we see enterprises thinking that cloud is not a specific place. It's more of a business model, and it's a set of attributes that they expect their infrastructure and their environments to be able to support. And that involves, some of the things we talked about before, the self-service aspect, the on-off consumption model, the automation for deployments and operations. And so what we're seeing is a plethora of different service providers providing value-add managed Kubernetes and providing application platforms for their customers. Which where StorageOS is providing that storage engine for. The second point is that I'm just kind of stressing this point, but all applications need state, right? The whole concept of stateless applications really is a myth. All applications are going to store something somewhere. And this is a fundamental challenge to enterprises adopting Kubernetes, and we're seeing the challenges with some of the traditional storage paradigms and storage providers struggling with the new cloud-native usage patterns, where we have sort of the concept of application-centric storage, where storage is no longer tied to servers but needs to be portable and move around with applications, and that's what StorageOS is solving. The third point and the 4 points are things which we're looking at to kind of shape some of the further developments that we're looking to build with StorageOS. So point number 3 is around the sizes of clusters. So early on, lots of enterprises built really large clusters and tried to do multi-tenancy. But what we're seeing more as a trend nowadays is a larger number of smaller clusters, and that can be for commercial reasons or technical reasons or operational reasons. But more and more, the requirements to share storage, to migrate applications and be able to consume storage and replicate storage between different clusters is becoming a serious need, and that's something we're building out at the moment. And the last point is, as we work with large enterprises who are adopting Kubernetes, they tend not to be able to just make this sudden switch to cloud native. They will always have upstream and downstream dependencies that continue to live in their traditional environment. And that's perhaps because they haven't gotten to it yet, or perhaps because there are some, operational and technical challenges. But either way, what we expect is more of a coexistence between the two different environments. And so we're building out a set of tools and functionality and data services that allow that make it easier for enterprises who are moving between these two different platforms. I wanted to just dive in and give you a little intro of what StorageOS is and kind of the shape of StorageOS, so that you'll be familiar with how we operate and the type of services that we provide. So StorageOS is in fact actually deployed as a container. We're fairly unique in our space in that we don't have any kernel dependencies. We don't have any proprietary hardware dependencies. So we're extremely lightweight container that can be deployed anywhere that runs a container, which nowadays kind of means everywhere. We virtualize the storage that's available on each of those nodes, and that can be, say, physical disk on bare metal boxes if you're running on-prem. It can be virtual disk and VMs if you're running in that environment, or it can be cloud disks in cloud environments. And we aggregate all of that storage into a pool which spans all of the nodes in the cluster. From there, we have our integrations with Kubernetes that facilitate the dynamic provisioning and the self-service aspect of the volumes. So we can create volumes that will power these stateful applications running in Kubernetes. And we kind of create a mesh where a volume can be virtually instantiated on any of the nodes within the cluster. So as nodes come and go, or nodes get scaled, or Kubernetes upgrades or changes to the running of the application, the data always appears as if it's local to the individual application. Within StorageOS, we have two core components. There's a control plane and a data plane. We have some interesting IP called disaggregated consensus in our control plane, which fundamentally means that every volume in StorageOS has a little mini brain that can independently make decisions around placement and failover. This is important for two reasons. It creates an extremely performant control plane because it removes those serialization points, and it allows StorageOS to process tens of thousands of requests in parallel at really with and allow sort of these really dynamic usage patterns within Kubernetes. And the second point is it makes us extremely resilient to transient errors. So, in Kubernetes clusters, we typically see a higher rate of change compared to some other clusters where, nodes get upgraded more regularly and clusters scale up and scale down, for example. And therefore, if there are transient network errors or things like that, the disaggregated consensus means that the cluster can heal and reconverge really quickly, and access to volumes remains untouched. The second part of StorageOS is the data plane. Here we provide the data services that you kind of expect from a traditional storage array. So things like replication to protect your data against, say, node failures or disk failures, and encryption and compression and thin provisioning and other services like that. But one thing we're really proud of is our performance. The whole end-to-end architecture has been designed to be extremely low latency. And as I'm sure you're aware, low latency directly translates to better transactions per second for databases and message queues, which are some of the key mission-critical use cases that StorageOS powers. And finally, I'd just like to talk a little bit about some of our integrations with some of the key distributions. So, we're certified and operate within the catalogs for OpenShift, and Rancher, and together with our operator, typically that means you can have a fully fledged StorageOS cluster up and running within a couple of minutes with either a single command or a single click on their consoles. So to wrap it up, we think that StorageOS provides this end-to-end platform. It effectively gives you, the self-service storage that enterprises have been clamoring for. It gives you the performance and the availability for the most critical applications, and it can run anywhere in an extremely lightweight footprint, and provides. We try and always do the right thing by the user. So we make it extremely easy to use, partly because it can be deployed anywhere, partly because we've done a lot of work to facilitate the automation and the deployment functionality. And we also do, things like security by default. So by default, we'll protect all of the endpoints. We'll automatically encrypt all the data in transit, etc., so that users effectively get this secure end-to-end enterprise storage platform.
I have a few questions about the architecture and what's actually being deployed on each node, and what the requirements are for each node to run StorageOS. So I'm assuming that the control plane is deployed as an operator. Is that the model you're using?
So we have. We're about to go into a deep dive, and Paul will actually go into all of these details. But at a very high level, we are just a single container. The container includes both the control plane and the data plane, and our operator effectively automates the deployment of that container and kind of takes care of all the little vagaries that exist within the different distributions and the different versions of Kubernetes, etc. But ultimately, it's a single lightweight container. We can be deployed on servers with a gig of RAM and a single core and a couple of gigs of RAM, which means that we operate really, really well with extremely good performance, even in really small edge type scenarios, all the way to being deployed in on-prem data centers on huge bare metal boxes with banks of NVMe disks, for example.
Okay, and I guess if I'm looking for storage solutions for my Kubernetes cluster, and I'm typically just using EKS, would there be an obvious advantage I would see to using StorageOS over the native solution on any of the hosted Kubernetes?
So one of the big benefits of StorageOS is it can be installed anywhere. So, if you're using StorageOS, the same bit of YAML that you use to deploy on test on your laptop, and the same thing that you use to put in your dev environment, what you use on-prem and in the cloud, is exactly the same config. So that's a huge benefit. But on top of that, we offer, the same set of data services and the same set of, encryption and security services in any one of those environments. So effectively, you're giving end users the ability to get the same class of services everywhere. And even in the cloud, for example, we find that customers really love the fact that we can replicate across availability zones and provide encryption using key management that the customers control rather than the cloud providers control, for example, and things like that.
Okay. Is there going to be a further expansion on the security piece of things? Because that's something I'm always curious about, is how is the encryption actually being done? Where are the keys managed? Those type of topics are pretty important, the details. So I'm not sure if there's going to be a demo or a session regarding that today.
No, we agree. And Paul is going to cover that in the next section.
Okay, great. Thank you.
So I think that my question was just answered. We're gonna cover key management and encryption in the next session, and are we also gonna get into a little bit of the performance, determining performance measurement characteristics and how you're measuring because whenever you abstract storage, whenever you virtualize a storage medium, there's that shim layer that can cause 0.01 to 10 times latency. Are we going to get into the nerd knobs of that?
I would love to get into the nerd knobs of that. we don't actually have a slide,
Okay.
but I'm very happy to talk you through some of this, because this is something we are actually very proud of. So actually, one of your colleagues, Chris Evans, recently did a very detailed performance report measuring, benchmarking our products and some of the other products on some of the other open source products on the market, and we basically excel in performance, and typically not by a few percentage points, but by many multiples, and we do that through a mixture of some of our on-disk format, and some of our architecture, and some of our threading models, and things like that. So there's a number of things that make us low latency, but we've certainly won many bake-offs just on performance. And latency is typically, even for replicated volumes, can be kept to sub 100 microseconds when you're using the right NVMe disks and things like that. So I think we're very focused on things like databases and message queues, for which obviously performance is one of those key determinations.
If if you're doing multi-cloud and you wanted to use this for like a DR, is there a white paper on that as well?
Today we don't see lots of customers do DR across clouds, but we do see customers do DR across availability zones, and we certainly have like financial services companies who are running that exact configuration, doing replication across different availability zones on a cloud, say powering a trading platform, for example.